Yo, hi guys, welcome back to my channel. So today I'm gonna be teaching you guys about binary. So what binary is basically it's basically computer language. Computer uses binary instead of actual numbers like 1 2 3 4 5 6. It's only 1 and 0 in binary. That's it. And there's like you can make like infinite and more than that numbers with just 1 and 0. And you might think why we use this instead of number system, or like the tally. If you don't know what tally is, basically like, in the prisons, in the movies, they like make these weird lines. Why don't they just use that, like 5 6? They can just use that, but it'd be too complicated. Too complicated for it to like even process that many numbers. So they use these instead, called binary. So this is called a transistor, and it works by sending us. It's basically a normal switch. It's basically this. This is a transistor, and transistors don't act, are also related to making logic gates. So yeah, that's kind of weird, but it sounds weird, but it actually isn't. It makes sense, because if you combine more transistors around, so basically what it happens here is there's a signal. Oh wait, there's a signal always going through here, like this, but it can't go through. I mean, yeah, it can't really go through, but it can't go through and come out over here. But then if you switch this on, when you switch this on, it can pass through and send a signal out here. Well, there's going to be a repeater here, but you get the point, right? So there's always a signal coming through there, but only if you switch this. I mean, it doesn't work because I haven't used any logic to even make that work. If it's on, it goes through from there, around up there, and then comes through there. And when it's off, it doesn't work. It's like, yeah, it doesn't work. So that's kind of how they work. And now let's get on to the binary bit. This is 5. So 1 0 1. You might be thinking, well, 1 0 1. That's 1 plus 1 is 2. So how is that 5? Well, if that's the case, why do you think there would be a 0 in the middle if it can be just like this, 1 plus 1 1? So what it is, I'm just gonna add the 0 back. I have made a big table here. Don't mind this, because I couldn't fit this to 0. It's kind of way on the wrong spot, but I couldn't fit the 0. So I made a table. On the top there, the numbers of the table goes 1 2 4 8 16 32 64. It's like going like the power of 2. Yeah. Oh, not the power of 2, actually. 2 4 8. Yeah, it goes like 1 2 4 8. I don't know how much is going up. And so you put that number. Let's just take that number and then put that in order. So the first number on that is 1. So I put the 1 in on top, under the 1. I take the 0 and put it in 2, under the 2, and then take the other 1 and another the second one and put it in under 4, so that'd be 101, as you can see there. So what you do is basically 0 is false and 1 is true. So if you see a 0, and whenever you see a 0 and there's a number on top of it, like any number, you don't take that number. So if there's like 1 here, you take this number, and then if, let's say there's another one here, you take this number and add them together. So if this was 1, 1, 0, 0, and so continuing zeros till infinity and beyond, I guess, it would be 1, 1, 3. The answer would be 3. 1, 2 plus 1 is 3. So you take these numbers, so that'd be 1 and 4, because 4 has a 1 in it, and a 1 has and the 1 over here has a 1 in it, but 2 doesn't have one, has one. So you do 4, you take that number, 4 plus 1 over there, so that'd be 5. And yeah, it works with anything. Let's say this was this. Let me just center it out. And we didn't have that, so that'd be 0 if it's blank. So we take 2 and 1 over there, and then we add. So 2 plus 1 is 3. That's easy. So whenever you're trying to figure out how to do binary, just draw a table and then make the sort the numbers out, and take the numbers which has the 1, a 1, this one, 1, and add them together. So that's how binary you read binary. And now let's get on to adding binary. So this is 101. In the table, that should be 4 plus 1, which is 5, also there. And then 10, that should be 2, because that's 0. So you're just taking 2 and adding nothing, so that'd be 2. So 1 plus 0 is 1. It's kind of simple maths. 0 plus 1 is 1. 1 plus 1 is 1. So if we try to convert this, that'd be 1, 1, 1. So 4 plus 2 plus 1, which is 7. 4, 5, 6, 7. And there's another way. So you can convert the top number, which is 5, and convert the bottom number, which is 2. And you can do the real addition to get the number. Like, yeah, real addition, as you can see. Now there's this carry stuff. So we have 1, 0, 1, 1. I don't know what that is. Let's see. 2 plus 1 is 3, and there's 1 in it, so 11. Yeah, that's 11 plus 1, 4, 5, 6. That's 6. 11 plus 6. So 1 plus 0 is 1, as usual. Now 1 plus 1 in real life and in binary is 2. And the way you write 2 in binary is 1, 0. And it makes sense. If you want to try that out yourself, you can do that with your chart. So how you do that is you write a 0, the first number in the column, and then you carry forward the 1 up here. It's kind of like maths. Normal maths. That's what you do. 1 plus 0 is 1. Plus 1 is another 0, because 1 plus 1 is 2. And then you carry forward that 1 over there. And then 1 plus 1 is, you can just write it as 2, as 10, because there's no more numbers to add. So I don't really know what that number is, but I think that's the right answer. And yeah, so everything in computers, in games, everything. I mean, mostly everything. Technology, basically. Everything has binary. Even this in-game stuff has binary. Look, so there's this thing called truth tables for logic gates, and this is a buffer gate. So the truth table will be 0. So input equals 0, then the output should equal 0, and then input equals 1, then the output equals 1. I mean, and then the truth table for this is gonna be if the input is 0, the output is 1, and then if the output is 0, the input is, wait, I just said it wrong. So let me say it again. I think I said it wrong. So the input is 0, then the output is 1, and then the input is 1, then the output is 0. That's like inverse. So this one has a bigger one. I'm not gonna say it because you guys might be confused. Everything has, I didn't know that happens. So everything has binary in it. Okay. So that's 0, 1, 0, 1, 0, and yeah, you can make all of these using just ones and zeros. I mean, yeah, I guess. Logic gates have ones and zeros. They have the truth table, and they have binary in it. I don't know why that came up. Which fire? Anyways, alright. Yeah, you can make everything out of it. Everything away. So, yeah, I don't know what's that. So yeah, if you did like this video, please do like, share, and subscribe. And yeah, make sure to stick around at my channel for more videos. And yeah, bye guys. Have a great day. Bye.